So, in today's class, we are going to understand the data structures and algorithms somewhat deeply. So, as I have briefed that data structure is nothing but it is a way to store the data in computer's memory. Okay, so that once data is arranged in a proper manner, so that it can be accessed efficiently. Its access will be efficiently in terms of time and space. Space is memory. Okay, so initially I told that there are two data structures, primitive data structures, that is the basic data structures provided by any programming language to store single values like integer, float, and char, bool, like whatever. And non-primitive data structures, they will be built with the help of primitive data structures. So non-primitive data structures examples are what? Your arrays, linked list, stacks, queues, graphs, like that. Okay, so examples of primitive data structures: integer, float, character, boolean. So non-primitive data structures, again they have been divided into two categories: linear and non-linear. This is non-linear, so they have written wrong. So linear data structure, in linear data structure, what happened? The data will be stored in sequentially. Sequentially means one by one. Okay, in consecutive memory locations. So example: arrays, linked list, tags, queues. Why? Because linear data structure again divided into two categories. One is the static, dynamic. So I told you that static is what? In static data structure, the memory size will be fixed. Okay, and the memory size will be allotted at the time of compilation time. So once memory is allotted, it can't be changed. But the elements stored in this structures, example array, elements can be changed, but the memory size can't be changed. Okay, in dynamic data structures are what? At the time of their memory can be flexible. Memory size can be changed. Flexibility is there. So the memory size will be allotted on at the time of runtime or execution time, and as well as the contents, the elements stored in memory location also can be changed in that dynamic data structure. Example: linked list, stack, and queue. Non-linear data. This is non-linear data structures. Okay, in non-linear data structures, the elements can be stored in random manner. Simply examples are tree and graph. So now try to understand, and that is what first we will try to understand arrays. Okay, as I told you that arrays are what? They are the data structures, examples of linear data structures. I told you that the data will be stored in consecutive memory locations, means sequentially. Consecutive, subsequent, all are equal. So data will be stored in consecutive means sequentially. See, suppose it is an array declared with 6 elements. Its size is what? 6. So 6 elements will be stored sequential manner, means this is the index position. So first location, memory location. Suppose if you assume that it is 1000 location. Next 1001, 1002, 1003, 1004, 1005. So like that. So first data stored at zero index. This is the position, 0 index, first position, second position, third position. So that last is the 5th index. Array indexes. Okay, elements these are. So the elements will be stored in sequential manner, one by one. Okay, so in arrays data will be stored in sequential manner, and once that is what the drawback is what? And arrays can be classified into different types: one-dimensional array, okay, two-dimensional arrays, and multi-dimensional arrays. In one-dimensional array, only one row of data elements. One row means array. Already we have studied that array will be used to store same type of data elements. Suppose same type of data means these are integers. So array will be used to store same type of data elements. If it is integer array, only integer data will be stored. Okay, this is called one row of data elements. So that's why it is called one dimensional array. We can also say that this is called homogeneous data structure. Homogeneous means, why we call it homogeneous means same type of data elements. Okay, if it is integer array, integer elements will be stored. If multiple mixed elements stored, that is called heterogeneous data structure. Suppose if a data structure capable to store integer, floats and char, strings like that, so in Python we can do like that list. Okay, so that they are called heterogeneous data structures. So two-dimensional array means array consisting of multiple rows and columns of data elements, two-dimensional. So multi-dimensional array. So whenever practically we do that moment, I will brief all the things. So simply you understand that. Okay. So array of arrays. A array is defined in another array. So one array is declared, within that is outside array, inside of one more array is defined. So that is called multi-dimensional array. A two-dimensional array called, these are 2D arrays. Okay, 2D arrays. Okay, next is what? So next we will try to understand linked list. So what is linked list? So linked list, another data structure to store collection of data elements dynamically. Why dynamically? What will be used means the memory size can be changed, and the elements as well as the elements also, whatever the stored, they can also be changed. Okay, the memory size is not fixed. That's why it is not part of static data structure. It is part of dynamic data structure. So dynamically means the memory size can be changed at the time of execution time, otherwise runtime, and the elements also can be changed at the runtime and execution time. In this data structure, data elements will be represented by the nodes. This is called one node. A node will consist of two parts. One is the data part, another one is the pointer. The pointer will have address to the next node. So every element and means data, and the pointer address to the next node is called a node. Okay, so this node is connected to the next node. This node connected to the next node with the pointer. So these are called, so one node connected to another node using links or pointer. That links are called pointers. So each node contains two fields. The information field means that is data field, and the pointer field consists of the address. The pointer field consists of the address of the next node, subsequent node. So the last node pointer having null means there is no any address. Null pointer means it is not pointing to anything. So the user can dynamically adjust the size of a linked list as per the requirement. As per his requirement, he can adjust the size, the memory size of the linked list. So linked list can be classified into different types: singly linked list, doubly linked list, circular linked list. Singly linked list, normal, this is the singly linked list. Okay, this is the most common type of linked list. Each node has its data and pointer field containing address. Doubly linked list, within this one information field, data field, and two pointer fields. These pointer fields, one pointer field and contains the address of the next node. Another pointer field contains reference to the next node. Okay, so So in doubly linked